Hello everyone. Today we will be talking about the magnetohydrodynamic effect, which is an interesting effect in which a liquid can be moved by purely voltage alone. So I have this little device over here, contraption meant to demonstrate it. But first I will talk about how this sort of stuff works. So here's my little pad, and the way that a railgun, or well, the magnetohydrodynamic effect basically takes advantage of railgun, is that there are two parallel rails over here, both of which are connected to a power supply, which has to be DC and has to supply very high current, uh, and and a wire shorts across this. And there's typically a long strip of magnet under here with exactly one side, so for example, north. And what this does is that the current is flowing through the wire, like so, and the magnetic field is going up into the screen. So, using the right-hand rule for the wire, the current would be flowing this way, the magnetic field would be going this way because it's pointed towards the screen. So then the force would be the direction of the thumb, which is that way. So if this circuit were to exist, then the direction of this little rail would go this way, and if this rail was a liquid, then the liquid will be channeled between these two and be propelled. So that's what I'm going to do with my little salt solution. I have a magnet over here, and well, let's just change out the stand for something more appropriate. That's better. There's the magnet. And now here is a salt solution in which I dissolved a completely random amount of magnesium sulfate into the water. Let's hook up the positive terminal of the battery to this electrode, which is just a piece of scrap copper wire. Maybe bend it into a more suitable shape and connect it up properly. And now, if I hold this over the magnet and put in a second piece of copper wire for the negative side, notice that all of the bubbles that are being produced as the electrolysis happens are moved. It might be a little hard to tell on camera. Let's move this away, but hopefully with a small piece of paper, it'll be easier to tell. So let's just take this piece of paper, plop it down right there, and see if it will move when the wire is inserted. Well, it would help if the battery was connected too. Come on, come on. It's moving slightly, just ever so slightly moving. Let's put it on the beginning of the magnet so that maybe it'll be a bit better. You should be able to see that that piece of paper is very slowly moving across. Isn't that a little cool? And the flow with this thing is absolutely pitiful because salt water, especially if the salt that you're using, like magnesium sulfate, isn't very soluble, is not very conductive. And if I were to take out the multimeter, which is conveniently already set in ohms, and measure across a completely random spot in the water, we have a resistance of around 17 kiloohms. Where's my light? Maybe like 18 or 19. Yeah, 20, 22. Hopefully you can see it right there. 23 something. If I had mercury, then you would be able to get some much better flows out of this, and if I had a higher current power supply. But I don't have mercury, which is probably for the better, because mercury is kind of, well, questionable, even though it isn't actually that toxic. But anyway, that's the magnetohydrodynamic effect.